Yeah, hello, welcome back once again. As I said in my last presentation, I told you I'm going to make another quick video on the refraction of light to conclude everything under light energy. So here we go. Light, I'm going to finish this with the refraction of light. And we will start by saying that refraction is the change in direction of light rays as it travels from one medium to another different medium. What do I mean by media? Or what do I mean by medium? We have some mediums, or we can talk about media such as water, air, glass. All these media, when light travels through, they may be refracted. Now, bear in mind, as the ray moves from one medium to another medium, its speed also changes. For example, the speed of light in air is 3.0 times 10 raised to the power 8 to the power 8 meter per second. But then when it comes to water, the speed of light will reduce to 2.3 times 10 raised to the power 8 meter per second. So this shows that light rays, when refracted, depend on the medium. One, they will have change in direction. Or two, they may also reduce the speed of light. All right. Let's also look at the law of refraction. And here, I'm just going to give you one of them for the sake of the JSS syllabus. So here we have that the incident ray, the refracted ray, and then the normal all lie in the same plane. I'll talk about this pretty soon. They all lie in the same plane. I think in the presentation before this, I talk about what it means to be in the same plane. So here we are with refraction. So here we go. We have the incident ray. Remember, please do not forget that over here we have the medium air, and comes here we have the medium water. So this is the boundary line. So we have the incident ray entering water, which is another medium. And let's look at what happens to the ray of light. It enters the water and becomes refracted. That is, the ray bends towards the normal line. So under normal circumstances, this should have been the normal path of travel. But then you realize that it has deviated or it has bent towards the normal. That is when light ray moves from air to water, the ray becomes or bent towards the normal. So we shall call this the angle of deviation. This is how much the ray has deviated. This is the angle of refraction. Once again, it is measured between the normal line and then the ray. And this is the angle of incidence. As I said, this is the incident ray. Please bear in mind, when I'm talking about the ray, is incident ray. But this is the angle of incidence. So please bear in mind of that wordings. Then we have the normal. As we all know, this is the normal. Let us continue. I want you to pay particular attention to these two scenarios. When what light ray is moving from air to water, it will behave differently as compared to when it is moving from water to air. Let's take a look. From air to water, you realize that the ray will bend towards the normal. So it has bent here towards the normal. But then if the ray is supposed to travel from water rather to air, take a critical look at this. It goes away from the normal because we have changed the media. Water is on top here, air is on top here. So over here, air was on top, water was on the bottom part. So the ray bends towards the normal. But when the water gets to the top, that's a denser media. We all know water is denser than air. So when a denser media comes on top, and then the less dense media comes to the bottom. Please, when you are drawing such a diagram, the ray should bend away from the normal. It's very important. Questions can be asked to illustrate this. Then let's look at applications of refraction. Where do we see refraction in our normal day-to-day activities? We have separation of white light into its colors by a prism. This is what we also call dispersion of light. We have formation of rainbows. We have the coin at the bottom of a container with water appears to be shallow. We have mirage. Pencils look bent in water. And then we also have the glass periscope. This is just but a few applications of refraction. So here we are, we have the dispersion of light. So let's see what happens. We are saying that when light, which is a ray here, enters this medium, so from air into glass medium, the rays becomes reflected. And depending on the components of the white light, this diffraction separates the components of the white light into these colors. That's how we are able to get different colors from white light. Please bear in mind, white light is a mixture of so many colors together as one. So when this light enters from air to glass, the glass, due to refraction, separates them according to their refractive indexes. And then we get different colors here, starting from red, ending with violet. Another application of this, which I can say we can also bring here, is the formation of rainbow. So these two are almost the same, just that here the glass prism is the refracting media, and then here water droplets form the refracting media. We'll look at that into details very soon. Now let's go ahead and look at what I'm trying to say. Now let's quickly watch this video to illustrate refraction. So here we are. We have the prism, we have a white sheet of paper, and then we can also have, we can fix it. So let's fix it in this, let's set up our diagram this way. All right, so we are continuing. So we have our source of light, or that's where the light will pass through. That's our prism. Let's see what is going to happen here. And that will be our screen. Okay. So when the light ray, let's say from the sun, passes through this hole so that it makes it pointed, it incidents on the glass prism and separates it into its components colors. If you have a glass prism at your home, I think there's something that you can try. Sometimes even when you have glass material, it can also perform this for you. So rugby, that's what we have. It separates into its components colors. Okay. Let us continue with our presentation. I think I can forward this so that, let's look at, yes, the application of this also in the formation of rainbow. So we have the sun providing us with its rays, and then have you asked yourself why rainbows are formed normally after it rains? Because we have a lot of droplets of water in the atmosphere, and this usually occurs after raining. So after it rains, we have this droplet of water around. Then let's see what happens. So as the ray passes through this droplet of water provides another medium for refraction to occur. So here, this rain droplet is acting as our glass prism. So let's look at it quickly. So that's what we see. It refracts, yes, it refracts the light, and we shall get our rainbow. We shall get our rainbow. I think my point is well made here. Let's continue. Another application of refraction is when we have pencil in water and it appears bent, so that There's the real bottom of the pencil, but you may see it over here because image from the pencil, when it gets here, becomes reflected. And as I said, we form a virtual image here. So you may try to get the pencil from here, but then you won't get anything until you get your hand to this part here. The same way, fishes in water uses this principle of refraction to swerve from their predators. So that if you are a human being trying to go and catch the fish, if you see the fish here, you will be deceived. It is rather here. Once again, images from the fish gets reflected and we get a virtual or a false image of the fish somewhere here. Also, another application is the mirage. On a hot sunny day, you see on the middle of the road, some distance away, it appears to be some water ahead. So that's what we call mirage. Also, on a hot day on the desert, at a certain distance away, you see some body of water appearing at a distance away. That's also another application. Let's look at how mirages are formed. Now we have image from the sky coming straight to your eye. Then, because it is on the hot, please remember, this occurs on a hot day. So because it's on a hot day, we have different layers of air, depending on how hot it is. So this part is very hot and somehow hot. As you go to the upper part of the sky, it becomes dense because the air there is not as hot as the one on the ground. So the one on the ground is very hot, therefore light in density, followed by the next layer in that order. So it creates that medium for refraction to occur, and then the image of the sky is seen on the ground together with the rays coming straight to your eye, and that is how mirages are formed in the desert or on hot road. So once again, we have the glass periscope where we have light coming from this time around. I think I presented in the first session. Here we are not using mirror, but we are using glass prism. So once again, rays enters it, becomes refracted inside, then directed to another second glass prism, and it gets here. So we have mirror, prism, periscope, and then we have prism, which is also glass periscope. So get the difference between the two. Okay, so that brings us to the end of another exciting session. I hope you have learned a lot. Please, I'm going to post this in addition to the first one I've posted. The two should be viewed together to make everything complete. Once again, do not forget to subscribe to my channel, and I look forward in answering your questions. Please look at the link below. It will take you to a Google form format questions. Yes, you can click on the link and answer the questions that I'll paste over there. It will automatically mark it for you so that you assess your score. It's good coming to your way. Thanks for watching. Bye. Please let me add that in my next presentation, let me quickly add this. I'm going to prepare something on hazard, and also we will then start our series on elements and compounds, and then writing and balancing of writing chemical formulas and also balancing chemical equations. So be expecting that. Thank you once again. Bye.